Balik.
Okay. Kana pre, kita na.
Loading ba? Okay, na.
Sige nga. Okay. Ayaw na pre.
Principle of a gyroscope. Next. What is gyroscope? A gyroscope is defined as the device has a spinning disc mounted on the base so that it can move freely in more than one direction so that the orientation is maintained irrespective of the movement in the base. Next, pre. This is the gyroscope diagram. First, we have spine axle. Spinal axle, this is the imaginary line that runs through the center of the rotor and along which it spins. The spin axis is always fixed in space, even if the gyroscope is moving. Next, we have the rotor. Rotor, this is the spinning mass at the center of the gyroscope. It's usually made of a heavy metal disc or sphere, and it's mounted on bearings so that it can spin freely. The faster the rotor spins, the more stable the gyroscope becomes. Next, we have gimbal. Gimbal, this is a system of rings that allows the rotor to spin in any direction. The gimbals are mounted on each other so that they can rotate independently. This means that the rotor can this This means that the rotor can stay level even if the gyroscope is tilted or moved around. Next, we have the gyroscope frame.
Frame pre.
This is the outer ring of the gimbal system. It's usually mounted on a base and it provides support for the inner gimbals and the rotor. The way the gyroscope works is that when the rotor is spinning, it resists any force that tries to change its orientation. This is because of the law of conversion of angular momentum, which states that the total angular momentum of a system must remain constant unless acted upon by an external torque. In other words, if the rotor is spinning in one direction, it will try to keep spinning in that direction even if it's tilted or moved around. Last is base. Base is just the base of the gyroscope. Next, pre.
Next.
Design of gyroscope. A gyroscope can be considered a massive rotor fixed on a supporting rings known as the gimbals. The center rotor is isolated from the external torques with the help of frictionless bearings that are present in gimbals. The spin axis is defined by the axle of the spinning wheel. The rotor has exceptional stability at high speed as maintains the speed rotation at the central rotor. The rotor has 3 degrees of rotational freedom. Next break. Gyroscope working principle. The working principle of a gyroscope is based on gravity. It is explained as the product of angular momentum, which is experienced by a torque on a disc to produce a gyroscopic precision in the spinning wheel. This process is termed gyroscopic motion or gyroscopic is defined as a rotating object's tendency to maintain its orientation. We know that the rotating object possesses angular momentum, which needs to be conserved. This is done because when there is any charge in the axis of rotation, there will be a change in the orientation which changes the angular momentum. Next break. The gyro compass and repeater system. The gyro compass and repeater system are two interconnected parts of a navigational system used primarily on ships and other large vessels. They work together to provide accurate heading information regardless of external influences. Next one. Gyro compass. Advantages and disadvantages. The advantages of gyro compass is that true north points directly to true north, eliminating the need the compass correction chart. Stability unaffected by magnetic disturbances, ensuring stable readings even if tur- turbulent condition. Speed achieves operational accuracy quickly after startup. The disadvantages: complexity, more intricate and costly than magnetic compasses. Maintenance requires regular calibration and maintenance to ensure accuracy. Spray. Repeater system. The gyro compass or repeater system offers significant advantages for navigation, particularly in large vessels and challenging environments. Despite their complexity in maintenance requirements, their accuracy, stability, and accessibility make them invaluable, invaluable tools for ensuring safe and efficient journeys across various domains. Next, pray. Characteristics of typical gyro compass. True north reference points to true north, not magnetic north, eliminating the need for compass deviations and corrections. Stability unaffected by magnetic disturbance or the vessel's movement, providing stable and accurate heading information even in turbulent conditions. Accuracy can achieve high level of accuracy measures in degree with proper calibration maintenance. Speed, which is operational accuracy quickly after startup, unlike magnetic compasses, which needs time to settle. Next page. Technical components. Rotating rotor. A rapidly spinning wheel or rotor mounted on gimbals allow for free movement in any direction. The rotor spin axis aligns with true north due to Earth's rotation and gravity. Gimbal system provides a platform for the rotor to move freely and maintain its alignment with true north despite the vessel's movements. Sensors and electronics measures the rotor's orientation and convert it into heading information displayed on dials, indicators, or digital screens. Typical gyro compass offers superior accuracy, stability, and true north difference compared to magnetic compasses. However, its complexity in maintenance requirements, along with its higher cost and vulnerability, makes it a suitable choice primarily for large vessels, aviation, and aerospace applications where precise navigation is crucial. Explain. Transmission of the gyro compass heading to the repeaters. A gyro compass is a type compass that uses gyroscope to sense true north. The transmission system is the image is used to send the gyro compass heading to repeaters. Repeaters are displays that show the heading of the compass in different locations on the ship. This allows the crew to see in heading from anywhere on the ship without having to go to the compass itself. Master compass origin. The, mas- the master gyro compass generates the accurate heading information using its spinning rotor aligned with true north. Transmission unit bridge. It converts the heading data into electrical signal. analog or digital for transmission. Diverse transmission paths. Electrical wires, traditional methods for analog repeaters using physical cables. Data networks. Modern system often uses Ethernet or fiber optic cables for digital signals. Wireless systems. Some systems of for wireless transmission for flexibility. Repeaters receive and display. Analog repeaters contain smaller gyroscopes synchronized with the master. Display heading on dials or pointers. Digital repeaters receive and interpret digital data signal. Display heading numerically or graphically on screens. Explain. Starting, settling, and adjusting a gyro compass from shut-off condition. Pre-start up checks. Power supply. Ensure the power supply is connected and punctuation correctly. Fluid level. Verify that the gyro compass has sufficient fluid to operate smoothly. Physical condition. Inspect the unit for any sign of damage or loose components. Start up sequence. Power on. Activate the power switch to initiate the startup process. Warm up. Allow the gyro compass to warm up for a specific period, typically around 30 minutes to stabilize its internal components. Rotor spin up. The rotor will gradually accelerate to its high speed operational state, which can take around 4 to 6 hours. Observe heading display. Monitor the heading display as the rotor spins up. Erratic reading. Speak erratic readings initially as the rotor gains use the align with true north. Setting time. Allow sufficient time for the rotor to settle, typically around 6 to 8 hours. Adjustments. Initial readings. Once the heading display settles, compare it to the known reference heading. Adjustment knob. Use the adjustment knob if available to correct any minor discrepancies between the gyro compass reading and reference heading. Automatic adjustment. Some modern gyro compasses offer automatic adjustment features. Next, pre. Identify the display. Locate the primarily display and unit of the gyro compass, often situated on the bridge. If available, consult repeaters located in other parts of the vessel for redundancy. Observe the heading indicator. Dial or digital display. With the numerical heading value displayed, typically in degrees from 00 degree to 359 degree. Pointer. If using a dial, follow the pointer to the corresponding heading value on the scale. Align with ship's direction. Imagine a line extending forward from the ship's center line towards the bow. The heading displayed on the gyro compass represents the direction this imaginary line pointers in relation to true north. Next, please. Understand course and heading. First, course. Intended direction of travel. Heading. Actual direction the ship is pointing. Use heading information to determine course corrections needed to maintain the planned route. Ensure accuracy. Allow for full settling time after startup to 6 to 8 hours. Adhere to regular maintenance schedules. Be aware of potential impacts from environmental conditions. Switching on the aligning gyro repeaters with the master gyro. Confirm master gyro status. Ensure the master gyro compass is fully operational, settled, and providing accurate readings. Power on repeaters. Ensure the master gyro compass is fully operational, settled, and providing accurate readings. Align repeaters. The exact process varies depending on the system. Manual alignment. Use adjustment knobs or buttons on repeaters to match the readings with the master compass. Automatic alignment. Initiate automatic alignment features. If available, follow manufacturer's instruction. Verify synchronization. Carefully compare heading readings on repeaters with the master compass. Use adjustment mechanism.
Okay. Na-record, pre?
Record. Yari ko na kinabubuan.
Nakita ra tong naong?
Kita ra.
Gigi.
Basta pre.
Kani switching. Di makita tong naong sa
Basta kung
video.
ha?
Di makita tong naong sa video.
Mo ha?
Wala, kita.
Kita ra ni mo.
Gi.
Basta ka ng slide pre.
Ala sa switching. Ila. Tara. Mau ba ni? Ila. Tara.
Switching on the aligning gyro repeaters with the master gyro. Confirm master gyro status. Ensure the master gyro compass is fully operational, settled, and providing accurate readings. Power on repeaters. Ensure the master gyro compass is fully operational, settled, and provide accurate readings. Line repeaters. The exact process varies depending on the system. Manual alignment. Use the adjustment knobs or buttons on repeaters to match the readings with the master compass. Automatic alignment. Initiate automatic alignment features if available following manufacturer's instructions. Verify synchronization. Carefully compare readings on repeaters with the master compass. Use adjustment mechanism to fine-tune repeater readings until they align perfectly. Next way. Always consult manufacturer's instruction. Refer to the specific guidance provided for your system for accurate procedures. Manual alignment steps. Find adjustment knobs or buttons on repeaters. Gradually rotate knobs or press buttons while observing heading display. Continue until repeaters reading match the master compass heading precisely. Troubleshoot. Consult the manufacturer's manual for troubleshooting guidance if alignment issues persist. Seek assistance from a qualified technician if needed. Next week.
Next.
Next. What is gyro compass alarms? Gyro compass alarms are crucial warning systems on various seafaring vessels. From small boats to massive tankers, they alert the crew potential issues with the gyro compass, a vital navigation instrument that provides heading information based on the Earth's rotation. Next way. Gyro compass alarm. Of course, alarm. This alarm indicates that the vessel has deviated significantly from its intended course. Next.
Yeah.
Power failure alarm. This alarm signifies that the gyro compass has lost power, meaning it can no longer provide reading information. Dili ra ko to, pre.
Dira. Speed ay sa speed alarms. O, dihara ko to. So,
Ari ka sugod ka. Kuan.
ah,
Ari ka sugod sa speed alarm.
speed alarm. So, asa na nga number? 21 na. Sakto day. So, ni.
I-off ang screen record.
Nalay. Speed alarm. So, speed alarm is some gyro compass that has speed alarm have alarms that can be set to sound if the vessel speed exceeds a certain limit. So, speed alarm is a type of navigational alarm that is used on board ships and aircraft, and it is designed to warn the crew if the vessel is deviating from intended course by more than a certain amount. The alarm is triggered by a gyro compass, and which is a device that uses rapidly spinning gyroscope to sense true north. The gyroscope is mounted on a stable platform that is not affected by the movement of the vessel. As the vessel turns, the gyroscope remains pointed in the same direction to determine the ship's heading. So the speed alarm is also connected to, I mean, it is connected to a speed sensor which measures the vessel's speed through the water. The alarm is set to a certain threshold speed, and if the vessel exceeds that speed while deviating from its course, the alarm will sound. These are the few different reasons why a gyro compass speed alarm might be triggered. One possibility is that the vessel is simply going to pass for the current conditions. For example, if the vessel is a narrow channel or in heavy traffic, and it may need to slow down to avoid hitting something. Another possibility is that the vessel is being steered off course by the wind of the current. In this case, the alarm will sound to warn the crew that they need to take corrective action to get back on course. These alarms are typically set to sound when the vessel is deviating from its course by more than 5 degrees, and they can be adjusted to a different threshold speed depending on the conditions. So some gyro compass speed alarms are also have a visual indicator such as a flashing light that is activated with the alarm sounds. And gyro compass speed alarms are an important part of vessel overall navigation system. So, system fault alarm. So this is a generic alarm that indicates that the gyro compass has detected an internal fault. So gyro compass alarm system fault alarm is an alert triggered when the gyro compass is system encounters an error or malfunction. It's a crucial safety. feature aboard ships and aircraft. So, safeguarding against navigational issues that could lead to accidents. The gyro compass, this sensor uses a rapidly spinning gyroscope to determine the true north and unaffected by the vessel's movement. So, sensors like in acceleration, accelerometers or a magnetometers may be present to aid in accuracy and redundancy. So the processing unit of this analyzes the data from the gyro compass and other sensors to determine the vessel's heading and orientation. Ay, wala. So there are the potential causes of gyro compass failure. The gyroscope itself might malfunction due to mechanical issues, electrical faults, or environmental factors. And so IMO standards for gyro compass and repeater system. The International Maritime Organization or IMO sets port performance standards for, for gyro compass use on various seafaring vessels to ensure safe and accurate navigation. These standards are outlined in two main resolutions. So the first resolution is Resolution A424 adopted in 1979. This resolution applies to gyro compasses on ships operating below 30 knots. K performance requirements include, so there are K performance requirements that are included to the resolution. So first is accuracy. Accuracy settle time within 3 hours in latitudes up to 60% 60 degrees. Settle point error not exceeding 0.75 times second latitude at any latitude up to 60 degrees. So repeatability of the settle point error within 0.25 degree times second latitude. So the second is the performance under operational conditions. So transient and steady errors due to ship motions, rolling, pitching, yawing, and with simple harmonic motion of 6 to 15 seconds period. Maximum angles of 5 degrees, 10 degrees, and 5 degrees respectively. And a maximum horizontal acceleration of 0.22 meters per second squared, not exceeding 2 2.5 degrees times second latitude. Repeatability of heading indications from repeaters under all operations condition not exceeding 0.5 degrees. So in shipboard routine maintenance for gyro compass and repeater system. So maintaining a gyro compass and a repeater system is crucial for safe and accurate navigation. Here's guide to routine maintenance procedure on board. So first is the daily. So ilan na ka po? There are 5 daily procedures maintenance on board. So first is visual inspection. So visual inspection is for checking for any physical damage to the gyro compass and alarms. Repeater units such as cracks, leaks, or loose connections. So second is power supply. Power supply verifies the compass and repeater units and receiving the correct voltage and amperage. And the third is alarms. So alarms is a test all alarm functions to ensure they are working properly. So first is weekly. I mean, second is another is weekly. So cleaning. So use a soft dry cloth to clean the exterior surface of the compass and repeaters. Avoid using harsh chemicals or solvents. Then monthly leveling. Check the leveling of the gyro compass platform using a spirit level. Ensure it is a level within the manufacturer specifications. So, errors of gyro compass under corrections. While renowned for their precision, even gyro compass are prone to errors that can throw off your heading readings. Understanding these errors and correction methods is crucial for safe and accurate navigation. So, here's a breakdown of some common culprits and how to keep your course true. So, precision errors cause Earth's rotation and the gyroscope's own rotation interact, causing a slow and gradual drift in the compass north reference. Impact. The compass heading drifts slowly over a time. Correction. Modern gyro compasses automatically apply precision corrections through internal mechanisms. However, periodic calibration against known reference points like lighthouse or celestial bodies and remains essential for maintaining accuracy. Second is speed error. So the cause is rapidly changes in the vessel speed, particularly acceleration or deceleration can temporarily affect the gyroscope stability. Impact. Impact compass heading may exhibit momentary deviations during periods of rapid speed changes. So there are the changes of deviation during periods of the speed errors. So the correction, modern gyro compasses often have built-in features to compensate for speed errors. However, maintaining smooth speed adjustments can help minimize these temporary fluctuations. So by maintaining smooth speed, it can help to minimize the temporary fluctuations, latitude, or damping errors and the actions to correct them. So latitude errors. So what is like the latitude errors is the cause of Earth's rotation speed varies slightly across different latitudes, affecting gyroscope behavior. And the impact is heading readings may be slightly inaccurate, especially at a higher latitudes. Corrections. Latitude correction tables and algorithms. The- Most gyro compasses automatically apply this. Manual adjustment may be needed for older models or specific situations. Uh, Next is verify with another navigational aids. Always consult chart, GPS, etc. for confirmation. So there are three corrections for latitude errors. So damping errors. Damping errors cause improper damping mechanism controlling gyroscope oscillations leads to unstable readings. Impact. Compass may exhibit excessive oscillation or sluggish response. Corrections. Adjust damping mechanism. Use manual or automatic control as per the manufacturer's instructions and regular maintenance. Regular maintenance ensure damping mechanism is in good working order. Monitoring heading stability. Observe compass readings for signs of damping issues. Course errors. Course errors impact discrepancies between the vessel's actual course and course indicated by the gyro compass. And the impact of course errors can lead to inaccurate navigation and potential hazards. So, the correction of course errors first is comparison with another navigational aids. Regularly compare gyro compass readings with magnetic compass, GPS, wala akong kuhan, GPS, nautical charts, and visual bearings to detect correct course and errors. Ano ni? Nawala akong kuhan pre, video.
Oo, pre naman.
Nawa no? So make sure I'm stable to detect camera. Sa wala akong video. Di ni makita ron. Ana, kita na pre. Tara, tara, tara. So, magnetic compass, GPS, nautical charts, and visual bearings to detect and course errors. Calibration. So, calibration for course errors is if discrepancies persist, calibrate the gyro compass by aligning it with a known reference point such lighthouse or celestial body. Maintenance. Maintenance ensure proper maintenance of the gyro compass to minimize errors including regular cleaning, lubrication, and inspection of components. So course and speed errors, the actions to correct them. So uh, to correct the speed errors, the cause of speed errors, rapid acceleration or deceleration of the vessel can temporarily affect the gyroscope's stability, leading to a brief inaccuracies in headings reading. So the impact is may cause momentary confusion or navigational errors during speed changes. And the corrections of speed errors is smooth speed adjustments, minimize speed errors by making smooth, gradual changes in speed rather than abrupt accelerations or decelerations. Built-in correction features. Many modern gyro compasses have built-in features that compensate for speed errors, cross-checking with other instruments, verify speed readings with other instruments like log, GPS, or Doppler sonar for accuracy. So these are the correction for speed errors. These are the three correction for speed errors, mode speed adjustments, and built-in correction speed features, cross-checking with other instruments. So tilt errors and actions to correct it. Tilt error. What is tilt errors? So they occur when the gyro compass platform is tilted or not perfectly level. This tilt can be caused by ship's move ship's movement, rolling, pitching, yawing, and improper installation or leveling of the compass. External factors like rough seas or strong winds. So tilt error refers to a type of measurement error that occurs when a sensor or device is not perfectly aligned with the intended axis of measurement. And less common issues in various fields including accelerometer measures. Gyroscope measurement tilt can introduce errors in gyroscope readings affecting navigation and orientation system. The, the impact of tilt errors in accurate readings, difficult maintaining a steady course, potentially navigational hazards. Actions to correct tilt errors, leveling the gyro compass platform. Use a spiritual level to ensure the platform is perfectly horizontal, adjusting level screws or gimbals as needed in correcting tilt errors. Third is recheck level frequency, especially in rough seas, like I said before. So next is built-in tilt sensors and correction systems. Many modern gyro compasses have these features to automatically detect and compensate for tilt, ensure they're enabled the functioning correctly. Correct. So actions to correct is that they minimize shift movement. So to correct to correct tilt errors is to minimize shift movement, adjust the speed of or the course to reduce rolling, pitching, and yawing. Seek calmer waters or sheltered areas when possible. Next is regular maintenance and calibration. Ensure the gyro compass is in good working condition. Schedule regular calibration by qualified technicians. So, error caused by acceleration of the of the compass. So error caused by uh, acceleration of the compass, particularly a uh, uh, compass are known as acceleration errors. These errors occur due to the inertia of the gyroscope within the compass, which can lag behind the actual changes in the vessel's motion during sudden accelerations or deceleration. So acceleration error, also known as the inertia error, is a compass error that occurs when a compass is subjected to external acceleration forces. Is a, is a subjective subjected to external acceleration forces, causing temporary deviation in its readings, in which is primarily observed in magnetic compasses, which rely on a magnetic needle to align with the Earth's magnetic field. So, in depth correction way, magnetic compasses have a small weight attached to the south end of the needle to compensate for magnetic dip. So the downward inclination of the Earth's magnetic field, this weight slightly shifts the needle's center of gravity. And the acceleration or deceleration when the compass experience acceleration or decelerations, the inertia of this weight causes it to lag behind the needle's movement. This misalignment creates a torque that pulls the needle slightly away from magnetic north. Directional effects. The direction of the error depends on the compass heading and hemisphere you are in. Northern hemisphere acceleration on easterly or westerly headings causes the needle to indicate a false turn towards north. Deceleration causes a false turn towards towards southern southern hemisphere. The effects are opposite. Acceleration causes a false turn towards south and deceleration towards north, minimizing acceleration error. Maintain steady speed. The error is most pronounced during significant acceleration or deceleration. Maintaining a steady speed minimizes its impact. Avoiding abrupt maneuvers, minimize sudden turns or changes in speed to reduce acceleration effects on the on the compass. Compensate during the turns. In aircraft, pilots often apply a small correction to compass readings during turns to account for acceleration error. Refer to other navigation system, use their compass or GPS which are less susceptible to acceleration errors for more accurate heading information in critical situation. Acceleration error is temporary and disappears once the compass returns to a steady state. It's most significant during rapid acceleration or deceleration. Understanding and anticipating this error is crucial for accurate navigation, especially in aircraft and marine vessels. By employing appropriate techniques and utilizing alternative navigation system, the impact of acceleration error can be significantly mitigated. So there are the cause of errors caused by acceleration of the compass, particularly a gyro compass, are known as acceleration errors. So these errors occur due to the inertia of the gyroscope, like, like I said, within the compass, which can lag behind the actual changes in the vessel's motion during sudden acceleration or decelerations. The cause of error caused by acceleration of the compass, sudden changes in the vessel speed, particularly rapid accelerations or decelerations. The gyroscope's inertia resists these changes, causing momentarily maintain its prior direction. Despite the vessel changing course, so impact impact of temporary deviation in the displayed heading, indicating a turn in the opposite direction of the actual acceleration. This can be misleading and potential dangerous, especially during critical maneuvers. Severity. The magnitude of the errors depends on the rate of acceleration and the speed of the gyro compass. Generally, faster acceleration and older compass models with less advanced technology tend to generate larger errors. That's all. Thank you. Dah, wala lagi ito
You.
makuan. Wala lagi ni na-edit ng kuan sa. Pre, wala ma. Sa i-edit mo to balik pre. Ay sa PPT
Nag-record man
ba?
lang yun.
Wala lagi ni ma-delete lagi. Stop na.